Okay guys, welcome back to the second lecture on acids and bases for honors chemistry. So what we are going to do this week is look at how we identify substances to be acids or bases, and also how we write reactions using those things. Let's go ahead and jump in. So when we look at acids and bases and trying to determine whether something is an acid or a base, we have a few rules of thumb that we can use. The first thing is that if we have an ionic compound that contains hydroxide, it is often a base. So something like potassium hydroxide, okay, KOH. This would be, we would look at that with an assumption that is probably a base. Calcium hydroxide. We would look at that and say, okay, we've got a calcium a calcium atom that is paired with hydroxide. Calcium is a metal. This is ionic. There's a good chance that that is a base. There are other bases that you need to just memorize, and those are covalent bases like ammonia, NH3. So you can see that I have that one written here. That would be a covalent base. This would be an ionic base, meaning what? Of course, meaning it contains a metal, and this would be a covalent base. All right, different types of bases. Also, we know that if a covalent compound starts with an H, it is often, not always, but often an acid. We do have one exception to that rule, of course, which is water, H2O, which obviously starts with an H, but it can be either an acid or a base. So those are a few rules we can use to help us determine whether a substance is an acid or a base. But how can we do that more definitively? Well, we can look at how substances are reacting in a chemical reaction. So let's go ahead and take a look at one of those right now. So here's an example. We have sulfuric acid, H2SO4, I just told you what it was, plus potassium hydroxide. Oh, there's that hydroxide ion again, and it's going to make water and potassium sulfide, okay? But if we didn't know that it was an acid, we can look and see what's happening in the chemical reaction. So let's do that now. So remember, our acids are our proton donors. They're donating H plus ions, and our bases are our proton acceptors, okay? So when we look at this one, we see we start with H2SO4. We have this SO4 paired with hydrogen, okay? Now let's go ahead and look over at the other side of the chemical reaction. When we look over here, we see that suddenly the SO4 is still there, but the hydrogen is completely separate from it. It's gone. There is no hydrogen paired with it anymore. So this has donated its H's. They're gone, right? It's donated them to my hydroxide ion. And in that donation, a new substance called water is formed, okay? We can also see that this hydroxide ion, the base, this potassium hydroxide, accepted the proton from the sulfuric acid. So now we have H2SO4, it has donated its H's to the OH, making, right, when we take this, so this is my acid, and this is my base, and it makes different substances. That's the whole point of a chemical reaction. We have new substances. Now we don't have either of these substances that we began with, okay? A couple of things to remember, okay? One, you're going to always look at the reactant side of the reaction to find your acid and your base. Your acid and your base will not be located on the product side, okay? One of the reactants will be an acid, the other one will be a base. One of the substances will donate its hydrogen ions, that's your acid, and one of the substances will accept the hydrogen ions, that's the base. Now obviously, if we go back up here, we see even though this hydroxide ion accepted the H plus ions, right, it's donating them here, we get over here, we have something completely different. Right? Now we have neither sulfuric acid or potassium hydroxide, but we have totally brand new substances. So this is the acid, this is the base. On the product side of the reaction, we have neither an acid or a base. And we're going to talk about what we do have here in just a minute. This is a very unique type of acid-base reaction, okay? So your acids and base, always on the reactant side. One substance is the acid, the other one is the base. So the process of this happening, the hydrogen ions being donated and accepted, is the chemical reaction. And as that happens, you no longer have an acid and a base. You have two different substances, which are the products of the reaction. This is a particular kind of reaction that we call a neutralization reaction, where we take an acid plus an ionic base, and we make a salt plus water. Now, you think of salt, first of all, as sodium chloride, that is correct. That is a salt. That is salt. It's also a salt. When we talk about salt in this frame, we're actually saying any ionic compound. Okay? So what we're actually saying here is that our acid will donate its protons. The ionic base will take those. They will be replaced in a displacement reaction, and we will end up with an ionic compound as one of our products and water. Now let's look at that, an example of that in the reaction I have started here. I've got hydrochloric acid and calcium hydroxide. Now, you may or may not have recognized that this one was my acid and this one was my base. But if we know we're looking at an ionic base and an acid, then we know we're going to create a neutralization reaction. So how would we do that? Well, we know this is going to break off, okay? And it's going to pair with my hydroxide. And then we know that my chlorine is going to pair off, and it's going to pair up with my calcium. Now, this should be striking some type of remembrance in you of a particular chemical reaction. These two are going to pair up, and these two are going to pair up. What kind of reaction is that? Hopefully you're remembering. It is, of course, a double displacement reaction. So let's go ahead and do that. All right, so we have calcium chloride, calcium and the chlorine pair up, and then we know that that's our ionic compound, and then we know we're also going to make water. Now, this is not perfectly correct. Why? Because calcium as an ion has a charge of 2+, and chlorine as an ion has a charge of 1-. So if I'm going to make this be a neutral compound when I form it, y'all know how to do this. This needs to be CaCl2. Obviously, I'm still not done with this because why? Well, I've got to balance my chemical reaction. Hang on, I'm looking for my notes because I already had that done. And when we balance that, we get, 1 second. Hang on, I'm finding it. Yeah, 2HCl plus CaOH2 makes CaCl2 plus 2H2O. So we start with 2 moles of hydrochloric acid, 1 mole of calcium hydroxide, and that forms 1 mole of calcium chloride and 2 moles of water. And that would be a balanced chemical reaction, a neutralization reaction between calcium hydroxide and hydrochloric acid. All right, that is our neutralization reaction. We have another type of reaction that you will be writing, and that would be when you have it's called a covalent acid-base reaction, where we have a covalent base. This is an ionic base, this calcium hydroxide that we worked with in the previous reaction. Now we're going to look at a reaction with a covalent base of ammonia. Now you just need to know that if you see NH3, it's ammonia, it's a base. You just need to know that. And actually, these types of reactions are actually a little bit easier to write. This is one of the rare reactions in which when you write out a balanced chemical reaction with this, what you will end up with is ions. Okay, so let me explain how this works. So again, this is our substance that starts with H. Okay, I know that ammonia is a base, so that is my base. It's going to accept the protons, and I know that H2SO4 then must be my acid. It's going to donate them. Okay, now what happens then is these H2s, this peels off, okay, and what I'm left with on the reactant side, on the product side, what happened there? That was strange. Let's go back. On the product side, I'm left with SO4, okay? And that is going to have a charge to it. Since I have two H's, that tells me my overall charge then would be 2 minus. And then I take my H that I peeled off, and I'm going to add 1 to this, to my NH3. And that would be making this one NH4. It also is going to have an overall charge of plus. Now, you may be saying, wait a minute, I peeled off 2 H's and I only added 1 over there. We'll talk about that in a minute, but just I want you to understand that when you peel the H's off and you add it to another compound, you will only always add 1 H to it. And you will adjust for how many H's were donated by balancing your chemical reaction. In this case, we would end up with 2 of those and 2 of these, and that gives us a balanced chemical reaction, okay? So that would be a covalent acid-base reaction. Now let's talk for just a minute about the fact that we have some substances like sulfuric acid, which can donate more than one H plus ion. We call these polyproduct substances. Poly means many, product means proton, so they can donate more than one H plus ions, okay? And that is what you just saw happened in that reaction up above. And so then what happens again, because you only are going to add 1 H to the ammonia to create ammonium, but the reality is that by doing the balancing, the fact that 2 of them were donated ends up showing here, right? So we end up with this NH, H, H, H. Oop. Right? There's NH4, it's got an overall plus charge, but the reality is in my balanced chemical reaction, because of the fact that I actually donated 2 H's to the ammonia, I end up with 2 of these NH4 molecules. So that's a polyproduct substance. In the book, he also talked about the fact that there's a particular way that you can write a polyproduct substance to show that it was donating more than one. He gave you the example of malonic acid, which is C3H4O4, and he told us that that is a polyproduct acid that can donate 2 H's. So then what you would do is you can write H2C3H2O4. So you're showing that you have a total of 4 H's, but by writing the H2 at the beginning of the compound, you're identifying that that is a polyproduct acid that can actually donate 2 H's. So there you go. Also, just FYI, there are absolutely 2 ions that you need to memorize for this chapter. One, of course, is hydroxide. That is OH minus, and hydronium, which is H3O plus. And that takes us to our last topic of the day, which is the pH scale. Let's take just a minute to talk about that. You read in the book that the pH scale has to do with the strength of our acid or our base. And if you remember back to our chapter on solutions, you remember when we have a solute that dissolves in a solvent. With acids and bases, we are absolutely dealing with solutions. The H plus ions that acids donate create this hydronium, H3O plus ion. And the pH scale is simply a measure of how many hydronium ions are present in a particular solution. If we have more hydronium ions, we have a strongly acidic solution. And if the number of hydronium ions decreases, then our solution becomes more basic. Strangely enough, the way the pH scale works looks like this. All right, this is 0, which is what we call neutral. When we move to the right, we have fewer hydronium. Let me go back here. Fewer H3O plus ions. And when we move to the left, we have more H3O plus ions. So when we move in this direction, our substance becomes more basic or more alkaline. And we move in this direction, our substance becomes more, sorry about that. Let's go back. more acidic. And our scale goes from 0 to 14. But, oh, this isn't, this is the neutral spot, and the number for neutral is right here. It's 7. So when we go this direction, we have 0, and all the way over here, we have 14, and in the middle is neutral with 7. So there you go. There's a few notes about the pH scale. We'll talk more about it when we get together. I hope this is helpful, and again, look forward to seeing you next Tuesday.